Hello everybody, this is Amel with another interview preparation video, and today I'm going to talk to you about this problem, the path sum problem. So giving a binary tree and the sum, determine if the tree has a root to leaf path such that adding up all the values along the path equals the given sum. A leaf is a node with no children. So for example, in this tree, and the sum equals 22. You want to check that there's a path in this tree that when you add up all the values in the path, you get 22. In this case, you return true because if you go from 5 plus 4 is 9 plus 11 is 20 plus 2 is 22. So this path here gives you 22. So you return true. So as I told you before, a tree is a recursive data structure. So one way to solve it is to use a recursion, and we can use one of the traversals of the tree, like the pre-order traversal. So we can traverse the tree and from the root, and we can check every path. We can check, for instance, 5, 4, 11, 7, and when we get to a leaf node, that is a node that has no children, we can check if the sum is equal to the sum we're looking for. So we can do a pre-order traversal. We can go first we check this path, then we check this path, then we check this path. If we find a path that adds up to the sum, all the values add up to the sum, then we can return true back up. We don't have to check the other parts. So without further ado, I'm gonna start. So if the tree is empty, if root equals null, I can return false. Then I'm gonna return a helper. This is gonna be a recursive method with a root and the sum that I'm looking for. So now private boolean helper, I'm gonna have the reference to the root and the sum. First, I'm gonna do a pre-order traversal. So the base case is if the root equals null. That means that I'm gonna go down this path, for example, and I'm gonna check the null link. So I want to return back up. So that means that I was not able to find this path does not add up to the sum, so I can return false. Then every time when I'm going down, I'm gonna say that the sum minus equals the value of the root, because I want to find a path that adds up to the sum. So I want to make sure that I decrease the sum by the value at each node. So when I get to a leaf node, I can check if the sum is 0. That means that all the values in this path actually add up to that sum. So I'm gonna, now the other case is if root.left equals null and root.right equals null. That means that this is a leaf node that has no children, and the sum is already equal to 0. That means that this path adds up to the sum, so I can return back up. I can return true. And as you can see in the pre-order traversal, we first process the node. So this is the processing that we do, and then we have to recurse to the left and to the right. So return helper root.left passing the sum, or helper root.right sum. So I go to the left looking for the sum. If I find it, then this is gonna be true and it's not gonna go to the right. But if I don't find it on the left, this is gonna be false. So it's gonna check the right. So if it finds it, it's gonna return true. If it doesn't find it, it's gonna return false. So now I'm gonna run the code. This is good. I'm gonna submit the code. Okay, so 1 millisecond faster than 29% of Java Online submissions for path sum. So the time complexity for this algorithm is big O of n. So thank you for watching this video. Don't forget to subscribe, like the video, and see you next time.